Hello, and welcome to Do Dancing Clams. This is a Blender 3.4 tutorial showing how to create and animate an alien tentacle ball. The purpose of this is to not only create a lovely visual effect, but also show several interesting techniques to shape and texture objects in animated projects. I finally found a use for 1D noise texture. All the animation is done inside geometry node groups from the frame number. No keyframing is done, and the node groups I have created for other animation projects are not needed here either. The other thing I have discovered while working on this is how animation and procedural textures can work together for some stunning results without the need for UV unwrapping. The project file for this is available on Gumroad. Just follow the link below. Also, I've had a few comments. YouTube doesn't always pick the highest resolution to display this video file in, so if you're having trouble reading the contents of the geometry nodes, just go into the YouTube settings and select 1080p resolution rather than auto. So let's take a look at where we're heading. First of all, I want the tentacles to shoot out and impact nearby objects. I want them to have a different look from when they're compressed, from when they're not compressed. I want the ball to pulse and wiggle as it moves through space while maintaining the same texture. I tried a version of this where the texture changed as it went through space, but the texture changed too quickly. It was like it was strobing. It wasn't good. This presentation of this idea is the simplest I could conceive of. The original thought was to animate a walking spider or a centipede or something mechanical from Star Wars. And I know those are all doable with the same technique. I chose this presentation to keep the size of this tutorial to a reasonable length. I will make extensive use of Node Wrangler in this, so make sure it's enabled by going to Edit, Preferences, Add-ons, Node Wrangler. And it is enabled. The other thing I'm going to do before I forget is change the rendering engine to cycles and GPU computing. If you have it, it speeds things up. And the other thing is, to start with, I'm going to use a very small number of frames because it works better for illustrations. So start at 0, go to 39, 40 frames. Now let's create some geometry nodes. We won't need the cube. And let's start by creating our alien ball. Now, what good would an alien ball be if it didn't pulse? So let's add a noise texture to cause that to happen. I'm going to use a noise texture for that. I'm going to set it for 4D now. In the final project, it doesn't matter, but this will help me illustrate what it's doing. The purpose of this add here, which should be a subtract, is to normalize the data. The noise produces values between 0 and 1, roughly. I want values between minus 0.5 and 0.5 to preserve the original size of the sphere. We also want a much smaller scale. I'm going to set this to 4D. We don't need it 4D. Moving the sphere through space will create the ripple effect we want, but changing it to 4D allows me to illustrate what's going on. The other thing is we're scaling the normal and using that to adjust the position of the surface of the sphere. We could use the position as well. They're almost interchangeable. They just provide slightly different effects. And in experimenting with this, I found the normal to be more pleasing for what I wanted here. What I didn't want is to take the noise texture almost directly into the set position. That gets rapidly out of control, and it doesn't lead to the sort of smooth effects I want. Scaling away from the center produces a much smoother result. And that is ideal. Do also want to cut down on the detail. Again, want smooth, pulsy, not like a chunk of granite. And let's shade the smooth. Do like to keep things organized. It just helps me when I look back at what I've done. To create motion in the sphere, to get the sphere to move, I'm going to create an ellipse and use the points along the ellipse to move the sphere to. Use a curved circle. For the resolution, this will match the number of total frames. So let's create a value for that. I'm going to take here, drag out into space, and type in group input. And that will create a new variable for our inputs, and it'll also show up under our modifiers, under the geometry node modifier. And we'll change this to match the number of frames we set in the render. I don't want this to be a circle. I think it's more interesting if it's an ellipse. You get it moving slower and faster at different parts of the cycle. So I'm going to make it eccentric in the x-axis. So these points will be used as the place to put the sphere. And we can do that with the set position. In order to make this work, we need to get the position from this geometry and copy it over to the sphere's geometry. We can do that with a sample index. The value we're going to copy is the position of one of the nodes along the ellipse. We're going to copy using the index positions of the ellipse, but the frame number is going to drive that. And now we get our first taste of animation. Let's make this bigger. Perfect. Okay, so this is the essence of the simple form of animation we'll be using. Take some geometry that guides a shape. In this case, our circular ellipse track. That track has 40 points on it to match the total number of frames. So at frame 0, we will copy index 0, and we'll use that to position our sphere. At frame 1, we'll take index 1 from this ellipse and use that to move the next position of the sphere to, etc. And because we set up our texture, it wigbles and wobbles as it goes through space. And just a little tidying up. So now we have the ball traveling through space. I want to create the targets for it. Bring up my favorite points. Create a variable so we can control this. Should be good to start. We'll create an extent that the targets will be within. And these are the initial setup points. We'll of course be messing with this over time. I want to create a box that's roughly matches the ellipse and also has some Z because it's interesting when the tentacles are not just staying on one plane. And we can always come back and play with this later if we need to. And now let's actually create the spheres on these points. And just for interest's sake, let's not make them all the same size. Control-Shift-Click so we can see what we just did. And that'll be nice. So these will be what our tentacles are connecting to. Now I chose a sphere because it's easy and it looks good. You can choose other shapes, but when you start getting into really elaborate shapes, you have to start worrying about where the tentacles are going to connect to them. So I'm just stuck with spheres to make it easy. And create a join geometry to let us see everything. Really like that alt-right drag thing. Gotta start using that more. Now let's create the tentacles themselves. This was a bit of an aha moment on the project. Originally I conceived of as the tentacles being part of the source ball, but that got really complicated. Turns out it's a lot easier to flip it and have the tentacles belong to the targets. That way there's one tentacle for every target. It may or may not be deleted if we don't need it for a particular frame, but this just makes everything so much easier to manage. Take the same points we used for the targets. Use my so-favorite curve line. Now I want to know the distance between where the source currently is and each target, and I will store that into an attribute to be used later. And this will be a distance. It'll be the distance from the position of the instance, which is just one of the points, and where the source is currently on the elliptical track. And we already have a sample index for that. So this is our ellipse. Grab the position, store it in an attribute. This will guide everything. If the length is beyond a certain distance, then the tentacle will be deleted. If it is very close to the target, the tentacle will be connected from the source to the target. And in between those two values, there's a range where it's moving toward the target. I don't want the tentacles to just suddenly appear. I want them to show motion. And let's see these tentacles. I want both endpoints to be where the instance is created. Realize the instances so we can get access to the individual splines. Do a set position on just one endpoint. And we'll make it the start. And then we have the basis for the tentacles. So there will be a tentacle connecting the source to every target to start with. And then we'll delete the ones we don't want. We will manage the endpoints for the ones that are in the process of connecting or disconnecting, and we'll also give these some shape. First, let's get rid of the lines that are too long. And I'm going to create two new variables. One that gives the maximum distance a tentacle will engage at, another value which is the distance over which a tentacle can be fully connected. I don't think 10.5 meters and 7 meters is good based on the other things we've chosen. And this store named attribute will be no good unless I put it in the right domain, which is instance. Now you can see, so we have the lines, and we'll just delete the ones that aren't close enough. Now let's handle the scaling for the tentacles. I want to come up with a number that describes the proportion that the length is between the reach distance and the attach distance. So get the value between these, so it'll be about 3.5 based on these values, and divide it by the length minus the attached length. And this will give us a number we can use to scale the tentacle. So this will cause tentacles that are between these two values to slowly extend. At least it would if it wasn't backwards. Yeah, there we go. So like this line you can see reaches out as it gets closer. Perfect. Later on when we increase the number of frames, this will look more impressive, but at least this tells me that it's working. Now it's time to give the tentacles some heft. Use a curve to mesh. Too much heft. That's better. And I need some more space. Now to make this more interesting, also I think these tentacles look good if they're narrow, close to the source, and they widen. So we'll use the factor on this spline parameter. That's a little better. We'll be messing with this a lot, so don't worry that it looks a bit thin. I would like to shape these tentacles in two different ways. One, I want to have regular ripples as it goes from end to end, so we'll accomplish that with a sine wave. And then I want to add some noise to that. We'll use the spline parameter factor again. Multiply by 19.3. That's just what I came up with last time. we want more than one just iteration of the sign. And the full value would be too much, so let's take that down a bit. And we aren't going to see much with just 2 points on the curve, so let's resample. That's more like it. Now for some noise. Now this is an interesting thing. I usually use 3D noise, which applies noise over the surface. But I don't want that in this case. What I want is to randomly vary the thickness of the line using the noise. So that's not even 2D, that's 1D. And we'll use the spline parameter factor for that. For the scale, I want to have it based on the length of the line. So the longer the line is, the longer the tentacle is, the less it's affected. To put that another way, the shorter the line is, the more prominent the noise will be. So we need a number between 0 and 1, roughly, to control this. We'll start with the length of the line and divide it by the maximum attached length. Now I want to play with this. Yeah, that's pretty much what I want. Almost looks like a turned dowel. It's a little obvious, but you want it to be a little obvious because when things are in motion, details get blurred. So this is kind of a stage makeup. You want the details to be a little bit exaggerated so you can see them even when things are moving. We are definitely getting there. And I just noticed the endpoints. End caps are not filled. Okay. One last detail that I think makes a huge difference is I want to have little suction cups on the end. So I want to flare out the end of each line. That's really simple. Use a math node and a float curve driven by the spline factor. And then we want, set that to asymptote. And then just give this a pleasing shape. Yeah, that'll work. I think it just adds so much to have a sucker. For the last part, we just need 3 procedural textures, which I kept deliberately easy. Create the textures and assign them. Tentacles for that one. The alien ball for that one. And the targets. I'm going to start with the targets because it's the easiest. Want something metallic. Not too rough, just to pick up some shine. Now let's do the alien ball. Bring up the shader editor. A dot to center our view. I'm going to drive this with a Voronoi texture. Let's scale this up to 30. And usually we would drive this with like the generated texture or maybe the UV if we'd unwrapped it. But in this case, I don't want to do that. I want to drive it with the UV map attribute. This is pre-crunched by Blender, and this provides just a simple UV map that's unchanging. It's perfect, exactly what I want. Now we don't want white and black, let's give it some pink. And we want a mix between black and pink. Let's make that a very dark gray, and make this a pink. And I used 9 Foxtrot 5983. I think that works. And we can also use this texture to drive the roughness. That gives a little shine where we want and dull where we don't. And we'll also use it to drive a bump map. Run it into the height of the bump map. And as always, way too strong. 0.117 for that. And we'll invert it so it's going out. And that will look beautiful. Now let's go for the tentacle texture. Again, I'm going to use a Voronoi texture. Control T to give us access to the texture coordinates. And we'll use the object. For this, I'm going to do a very similar color palette. The value again is 9 Foxtrot 5983. And for the gray, I'm going to use 2 Baker, 2 Baker, 2 Baker. I'm getting there. I also want to add some roughness all along this. And that'll be controlled with another Voronoi. Scale of 25, and I'm going to use smooth F1 this time. And it's going to be black. We'll use the first Voronoi texture for the roughness. And I want to invert this roughness. So take 1.24 and subtract the Voronoi from it. That'll give us something a bit rougher. Also to bump map. Invert that and set the strength to 0.15. Now I don't really want this spotty effect. What I really want is to have the Voronoi texture applied down the curve. I want to be able to access the curve factor and use that to drive this scale. That's really easily done. We'll just grab the spline parameter factor, store it into a named attribute, go back to the shader, and we use that to drive our scale. Better. I want to be able to make it a little bit more bold. You can see what it's doing, and it's just... that looks good. Basically just makes the colors and the bumps travel down the tentacle rather than be little spots all over. I think it helps it look more tentacle-y. Let's see what we got. Yeah, so the tentacles are going out, the ball is pulsing. Absolutely hideous. Now, the last thing I want to do before ending this project is go through a quick animation. Let's do some final tweaks to the animation. Go back to Geometry Node Editor. And I want 15. Just a little bit more crowded, a little bit more going on. Change this random number. I noticed that the ball is colliding with some of the targets, and I don't want that. So that might be better. The other thing I want to do is increase the number of frames to the final animation. So I think for this project, I'll go ahead and use 320. Which means I need to go up to the render settings. And 0 to 319 is the same thing as 320 frames. Try that. Yeah, that's good enough. Feel free to play with this until it makes you happy. The other thing I could have done is make sure that none of the targets are in the XY plane, providing a free path for the thing to travel, but too lazy. I want to change the world down to black. Check this again, and make sure that we're in cycles using GPU compute because this will take a while. And let's give a view. Someplace that looks decent. Oh, and the light. For quick and dirty, I don't think you can beat a sun. It's just one-stop shopping. Control-Alt-0 to place the camera view where our current view is. And to bring up this, go to View. Lock the camera to our current view. Let's do a test render, F12. I think that'll be fine. To render for animation, let's go back to the output properties. We want to save the individual files, especially with a render this size. You don't want to try to buffer the whole video in memory. So save out individual PNG files. I'm going to select a render folder to output into, and then render animation, or Control F12. And go get yourself a cup of tea. And sometime later, we have this, our last frame. And if you want to see the animation, you can do it directly. View animation. Buffers up everything in memory. And then you get to see it. So sexy. Now to produce a file is another couple of quick steps. Go to Video Sequencer, make sure we're at frame 0, Shift left arrow, add image sequence, select the 320 PNG files, and then back in our output properties, we switch this to FFmpeg. There's other settings you can play with, but the defaults are pretty good, especially if your goal is just to upload to YouTube. This is perfectly fine. And then again, Control F12. And then if that worked, we should be able to go to the render directory, and there's our movie file. I absolutely adore this style of animation. I think geometry nodes, while not replacing conventional animation, give a power and a simplicity that is a tremendous adjunct to traditional animation. I, for one, plan to use the hell out of it. For more simple animation, you can see the video on the left, my very first one. I really hope you enjoyed this. Thank you so much for watching.